All right, so I'm going to be talking about how to get the stack installed on your system, how to get LSST software installed in your system. So there are a number of different ways to do that. The official way to install the LSST stack is from source, so to build everything from source. The instructions for that are on dm.lsst.org. That is by far the most flexible way to do it. It's useful for developers. It makes it very easy for you to pull in new changes from Git and rebuild if you're chasing bugs. But it is a problem and a barrier to entry for someone who just needs to install it to start using the stack. And so a number of people have contributed binary builds. So there are a few different ways to get binaries on your system without having to build everything. There's the CERN VMFS system that Fabio Hernandez put together. So if let me see, I have it in here. So it's in Fabio's GitHub page. You can see all the details and pluses and minuses of that system. There's also a set of Docker containers that Andy Connolly, I think, and the Sims group put together for the LSST Science Collaborations meeting on observing strategy. You can read more about that at this URL. And again, this is recorded, so you can grab the URL later on. But the thing that I'm going to be talking about today is a way to install the stack using Conda packages or using the Anaconda Python software distribution. And what I'm going to be going through essentially is what's written in this gist. The URL is kind of long and unwieldy, but if you go to ls.st/k2i, that will get you there. So ls.st/k2i. So just a very brief introduction for those who have never used or seen Anaconda. What is Anaconda? Anaconda it's a distribution of Python built and distributed by a company called Continuum.io. It's free. I think it's BSD licensed, so it's very, very free, and you can do whatever you want with it. The nice thing about Anaconda is that you download this one big binary blob. So in this case, what is this? About 300 or 400 megabytes. You unzip that, you get Python, you get an order of 300 packages, 300 most useful packages of Python, and you're ready to go in minutes. A lot of people are using Anaconda. It's become de facto standard in the data science community. So making the stack distributable through Conda is actually very useful, because if you don't have Anaconda Python right now on your machine, it's very likely that you will have it over the next few years. Now, Anaconda actually has two distributions. One is Anaconda. That comes with the 300 packages that I just mentioned. There's another distribution called Miniconda, which just gets you the bare minimums, such as Python, and etc. So if I type Miniconda, here we go. So this here is Miniconda. The nice thing about Miniconda is you just install a very tiny limited distribution. It only has Python, and then after that you use the Conda installer to install the packages that you care about. The upside to that is that I can do this demo much quicker than if I used just Anaconda. So I'm going to be using Miniconda here, and also to demonstrate that when you install the stack with Conda, it will pull in all the dependencies that it needs. It knows about them by default, so you don't have to worry about whether you've installed this package or that package. So I'm going to be running this on LSST dev. That is a Linux machine. etc red hat release. So that is a CentOS 6 machine. As I'll mention in the end, these binaries should work on anything that's more recent than CentOS 5, including CentOS 5, and as well as on macOS 10.9 and 10.10. Okay, so let's do this. So I will go from scratch. So mkdir conda demo. Just create a directory for this entire thing. Go into the directory, and first thing I'm going to do is to download, oops, sorry about that. First thing I'm going to do is to download and install Miniconda. And you can do that by going to that web page and clicking on the appropriate installer. You will want the 64-bit installer for either Mac OS or Linux, depending on what you're running. We don't have 32-bit binaries. We don't have binaries for Windows either. I'm not sure if anyone's surprised by that. So I'm going to pull that installer. It's only 40 megabytes or so, and then I'm going to install Miniconda. And so it's the usual license. Yes, of course I've read it. Then it asks you where to install it. I'm going to install it into this directory that I just created. And we wait a few seconds. So the other thing that it asks you is, do you want to add it to your path in your bash RC? I typically don't do that because I want to control my path as necessary. But if I don't do that, then I need to add it to my path every time I want to run it. So that's what I do here. And there we go. So if I now say Conda, or if I say Python, if I look at which Python I'm working with, you will see that it's in the Miniconda 2 directory. So that's the Miniconda Python. And if I say Conda, which is the package manager for Anaconda, you will notice that Conda exists as well. Okay, so now I have my Miniconda distribution. If I say Conda list, it will tell me which packages I have installed in that distribution. By default, as I said, Miniconda comes with the bare minimum. So essentially it's Python and a bunch of support libraries. I can see which packages are available for me to install. I can say Conda search. That will contact the servers. That will contact Continuum servers and get me the list of packages. You'll notice many of them with different versions. I can say Conda search -- names only to get just a list of packages. And if you care about how many of them are there, I can pipe that to WC. And it's 480 packages. So this is the nice thing about Conda. It really packages a ton of things that people care about when analyzing data. These are not just Python packages. There's R in there. There are R libraries. There are many other things. And in addition to these packages, you can still use pip to install Python packages of your choice. Good. So how do we use Conda to install things? I can say, if I say Conda list, there's only Python here, for example. I want IPython. I can say Conda install IPython. Asks me to confirm, so it gets IPython, it gets everything that IPython depends on, and off we go. So this is very similar to the way every package manager out there runs. It's actually very similar to Yum on Red Hat. Good. So the thing with Conda, and by the way, just to demonstrate that I have IPython now, I can say IPython, and there it is, IPython 4.0. Now, if I do Conda search LSST, I get nothing. And the answer for that is because, of course, LSST software is not yet included in Conda's default repositories. So not everyone gets LSST out of the box. The way Conda finds packages and downloads packages is by looking at different URLs, which it calls channels. By default, there's only the Continuum's channel that it consults, that it looks at. To make it, to tell it where to look for LSST packages, we need to define the LSST channel. So to see which channels we have defined, I can say conda config -- get channels. The answer is we don't have any channels defined right now. And now I will add the LSST channel, and this is the important bit. So when you want to enable Conda to know about LSST repositories, you'll have to tell it conda config -- add channels, and then give it this URL. Now in this case, this URL ends in /stable. This is the channel where I have the most recent released build, so V11 of the DM code and the Sims code. There will also be other channels such as /dev where kind of more development releases are going to be going out, and you will. These are the sorts of things where if you need a particular feature that's only in the development release, you will add that channel and build from it. For now, I'm just going to demonstrate how to use what happens with the stable channel, or what code there is on the stable channel, but there's nothing different with any other channel. You can add as many of them as you want. So I say Conda add channel. Now if I look at what channels I have, it tells me that I have my LSST channel, and there's also the channel called defaults. Once you add a channel, it starts showing this default channel for some reason. Okay, there's nothing magical about what I just did. What this command did was to just populate a file called .conda.rc in your home directory. If you want to forget about all channels or all customizations to Conda, just delete that file and it'll go away. Good. So now if I do Conda search LSST, there we go. So now I see the entire stack. If Conda sees the entire stack, you'll see many packages in there. When you say Conda search LSST, it shows you all the packages that are in there, but typically there are a few that you really need to know about, and they will pull in all the dependencies that they need. One of them is called LSST apps. So if I say Conda search LSST apps, this is a top-level meta package that will pull in all LSST size pipelines. So image differencing, co-addition, single-frame processing, everything that's related to size pipeline processing you'll get when you install LSST apps. Another one to know about is LSST distrib. If you install LSST distrib, it will pull everything that LSST apps has, plus the middleware to run all of that on clusters. For now, it does not include the database, but ultimately I think it will include the database as well. The idea with LSST distrib is that you install that and you get literally everything. For the Sims group, another important package is going to be Sims Math. So if I search for, oops, what did I do? LSST Sims Math. If I search for Sims Math, here it is. That will get you the metrics analysis framework. And if you want all of Sims, you install LSST Sims. And now when I said search LSST Sims, it gave me all the packages that begin with LSST Sims. That's just the default behavior. I can add a -f switch, which means match only the full name, and it'll return the LSST Sims package. Okay, so those are the four, I think, most important packages to know about: LSST apps, LSST distrib, LSST Sims Math, and LSST Sims. Depending on what you're doing, you may want some or all of those. There's one other useful thing. You can think of this as more than just LSST code, because, for example, there's also Galsim in there. And Galsim is not that difficult to compile, but it's not easy either way. It's not easy either. So if you need Galsim, you may just want to grab a binary from here. Okay, now let's actually go and do that. The way to install things is to say Conda install, and then give it the packages that you want installed. So in this case, I'll say Conda install LSST apps, LSST Sims. And when I hit enter, it will go and download all the packages and install them. The difficulty for this presentation is that it takes about 5 minutes. It's still better than a couple of hours of building. So it just downloads and installs the binaries, but it's still 5 minutes, so I'm just going to skip that, and I'm going to cheat a little. I'm going to show you what the output would have been if I ran install, and this is what the output would have looked like. So it would find all the LSST packages, it would find all the dependencies, it would just go ahead and download them, just as it did when I was installing IPython, and you see it was 4 minutes and 19 seconds when I ran this. So instead of doing that now, I have a pre-built Conda distro or mini Conda distribution that I am going to copy instead. This should take about 20 seconds. And when this is done, we essentially have the entire LSST stack, LSST data management stack, and the entire LSST simulation stack installed. So if I say now conda list LSST, there we go. So all the packages are in there, and it took about 5 minutes. It would have taken about 5 minutes on this machine. Now, on your machine, it's going to be completely dominated by bandwidth, by network bandwidth, because it does need to download about 3 gigabytes of binaries and data and things of that sort, but there is no building. Now, next thing, if you now try to run something, I don't know, LSST, there's nothing like that. The first thing you need to do when you want to run a Conda installed package is you still have to set up EUPS, or you still have to tell your system or source, what should I call it, load EUPS. The way you do that is if you've installed the binaries through load LSST before, the equivalent of that script here is called eups-setups.sh. So you just say source eups-setups.sh, and at that point you have EUPS. So EUPS is here. You can do EUPS list. You see all the packages again. The way the Conda packaging works right now is essentially it wraps itself around the EUPS setup so as to mimic what you would have gotten if you built from EUPS. That is just to make our development easier, and it also allows some more advanced features that we might add later on. And now, for my last trick, I'm just going to demonstrate that this worked. So at this point, you should be able to import Conda modules and do work. So what I'm going to do is I'm going to pull the SimsMath contrib notebooks, and I'm going to open one of those notebooks, and I'm just going to run it. So let's go to tutorials. And I need just one file for this notebook to run. Okay. And now, as it says in the instructions for this notebook, I need to set up SimsMath to run this command to get SimsMath on my Python path. And I say Jupyter Notebook to start up the notebook. Okay, and so the notebook here we are. These are all the notebooks. And I'll open this one here, the introduction notebook. And here we go. So now if I evaluate this cell, it tells me which version I'm running. If I evaluate this one, it'll load all these modules, and that's basically the proof that all this works. And now I can go run different metrics. And let me just get to the first figure, because figures are usually good to convince people that the things worked. And there we go. So we've gone in about 10 minutes from having absolutely nothing on our system, including Python, or not even having Python, to having a working LSST stack on the system that and IPython and IPython notebooks that you can, with modules that you can load in IPython notebooks. Final bit, if you want to now clean up your environment, you can say unsetup SimsMath. And if you really, really want to clean up your environment, you can also say unsetup EUPS. And, oops. Yeah. So unsetup EUPS undoes that source EUPS setups.sh line. And so at this point, you have it. If you need to update it, if a new version comes out, you just say conda update, say LSST apps. Right now, it'll tell me that everything's already installed, but it should be as easy as that. And then I also have demos on how to, or there are examples on how to run the LSST stack demo, but I think in the interest of time, I'm just going to stop here and take questions. But the basic idea is that what we want to do with this is to make it very easy to get binaries onto your systems. Again, these binaries should work on virtually any relatively modern Linux out there and on Mac OSs. El Capitan doesn't work yet because of the way Apple changed some things in OS X 10.11. But it is something that we're working on, and when the stack begins working on El Capitan, we'll let everyone know. So that's it. One last bit is that so there will be an official sort of LSST binary distribution as well at some point that will use RPMs and debs and regular packages for Linux systems. But for now, this is one of the ways how to use it. Thanks.
Great. Thanks, Mario. And I can just tell everybody that I personally stopped building the binaries myself, and then both on my Mac and on the Linux machines here at Duke, I'm using the system, and it works incredibly well. So we have a few minutes for questions. I know the people at Slack have to leave at exactly 2 o'clock, so I'm going to let them ask questions first if they have anybody. If they have any, and I'm going to unmute whoever I muted on the phone. So if that was Slack, you should be able to talk now.
Can you hear me, Chris?
Yes,
Mario?
I can. Yes.
So just a simple question. So to install like all of Galsym, this is assuming 10 minutes would assume you already had Boost and TMB and the other stuff, wouldn't it? Or
yes, I have binaries for Boost and binaries for TMB and all of that. So if I say conda list LSST TMB, it should be there. Yep.
Okay,
yeah,
so
it will also install all the prerequisites that you need.
Right. Okay. Cool. Thanks.
Other comments or questions, especially from Slack people? Any non-Slack people? Okay, so I think it's clear. All right, so I think that's it. So let's. It's almost 2 o'clock, so I think it's time to finish the meeting. So thanks a lot to both KT and Mario for coming to our group and showing us this stuff. I think very useful for a lot of people to actually get started doing work. And we have one homework that came out of this meeting, which is that somebody needs to look at the mapper for simulation data. So that's something we'll start to think about. Okay, so thanks everybody. So I think we'll meet again in 2 weeks. And I just want to reiterate that if you have any work that you're doing, please let me know. And we'd like this meeting to be a place where people are showing updates of work that they're doing, not just complete jobs that they've already finished. It's a good place to get feedback over the last few months, doing some work and reporting on it in the meeting.
And
Okay,
Chris,
so have a good afternoon.
And Chris,
and I'll see everybody.
Before the last bit, the Conda stuff that I just demonstrated, Chris has been our heaviest user. So if you do find problems, please let us know. And Scott, Daniel, and I'm going to be very happy to follow up and fix any problems. Thanks.
Thanks everybody. Talk to you later. Bye-bye.
Bye.
Bye.